All right, thanks for joining us. This week's talk should be a topic that's familiar to a lot of you, especially those that are in the network measurement and monitoring space, of which I know many of you are. We're pleased to have Peter Boothe from Google, who's going to be talking a little bit about his work on the next generation of NDT, which is a tool that a lot of us are familiar with from our time many, many years ago. So I'm going to turn it over to Peter to talk about NDT.
Hi, my name is Peter Boothe. I'll say hi with the video on, and then I will switch to presenting. Just saying hello. I've been with the Measurement Lab project for 6 years now, and I've been working with the Measurement Lab project, and I work for Google as well. And part of the ways that Google supports Measurement Lab is by assigning me to write open source code in support of the Measurement Lab project. But I'm not speaking for my employer today because speaking for Google is very complicated and not what this is all about. So with that, I will share my screen and we can get started. Let's see, share, and all right. And I'm pretty sure we can all see this this thing. So I promised to talk about and want to talk about NDT, its evolution, and you. Google speaking. NDT is a diagnostic tool from Web 100. Web 100, and this is sort of level setting. Some of you know this, maybe a lot of you know this, was a late 90s, early 2000s project to instrument TCP in the Linux kernel to make sure everyone could run at the super fast speed of 100 megabits per second. Once you have instrumentation, you need a test that takes advantage of the instrumentation, and that's what NDT was. And just to really show that NDT was Web 100 and they really worked, the old binary was actually called Web 100 serve, and the old client was actually called Web 100 CLT. They really, they grew together. And it was written by Rich Carlson, or Rick Carlson. He goes by both sometimes. Thanks, Rich. The code worked. It was research quality, but it was popular enough that it received a lot of feature additions. People liked it. And it was maintained for years by Aaron Brown. Thanks, Aaron. It was integrated into Perf Sonar. Fortunately, I don't know who did that, so I can't thank them here. But the upshot is it required Web 100 patches to the Linux kernel in order to work. Those patches were rejected by upstream kernel maintainers. So was the successor, the Web 10G project. They were like, oh, well, we'll do it with Web 10G, make kind of Web 100, but for 10G links, it'll be better, it'll work. And then those were rejected also by upstream. The Web 100 kernel patches last applied cleanly in Linux kernel 2.6, 2.4. I mean, LTS versions, long-term support, but 10 plus years old, they've received end of life even though they were long-term support. They were long-term support ed, and now no longer are. Also, NDT was loved as a tool. People loved it, so they kept adding to it. It became a dessert topping and a floor wax. It captured all packets for the flows. Super great. That meant you had access to a ground truth. It snapshotted kernel variables for all the flows that it came into it, which meant that you could compare the packets and the kernel variables and watch them evolve together. It had a complicated protocol engine for running the tests. It had an expert system for providing recommendations based on the measurements. It also contained a web server because essentially every program that runs on a server grows until it can serve web content. And it had other tests besides bandwidth tests to try to determine whether middle boxes were present, but increasingly those, thanks, Rich, I didn't know. Oh, and hi, Rich. It had other tests besides bandwidth tests to try to determine whether middle boxes were present. And increasingly, whether middle boxes were present, the answer is yes. And it also got a multi-stream test hacked onto it at some point. It got big. It got a little too big. But let's back off and let's talk about how it worked, how it works and worked. The core functionality was a 10-second single stream upload and a 10-second single stream download, all instrumented. But the protocol to make that happen was a little bit complicated. You would connect to a control port to set up an upload test on a second port. You connect to that second port, upload for 10 seconds, receive the measurements on the control port, then use that control port to set up a download test on a third port. Connect to that third port, download for 10 seconds, receive measurements on the control port, and disconnect from the control port. The test is over. So we have like 3 ports, you have to, both the client and the server have to use them all the time. And it was all done with TLV style message protocol on the control port, setting things up and sending things back and forth. That was how NDT worked. There is a large deployed NDT client base. The clients didn't need anything special. They didn't need to have Web 100 installed. They didn't need a special kernel or anything. They could just use it. So there's a large client base out there. Lots of code uses it. Much of it by people who are unknown to MLab, actually. People just integrate it, and connecting to MLab is free, and you don't need to authenticate or anything. So people just connect to our NDT servers, and that's great. We get data, they get a service, everybody's happy. Sometimes we know the people, but the code isn't upgradable because they deployed code a long time ago, and they don't have access. They can't deploy that code again. But the longitudinal data produced by these clients is important. NDT is here to stay, at least from the client's perspective. Then in 2008, Measurement Lab was formed. Measurement Lab is an academic plus industry plus academic plus nonprofit partnership to measure the internet. Needed some software to run on its infrastructure, and it chose NDT. Some companies that needed speed tests used NDT against MLab systems, like I said, and MLab, and therefore everyone, because MLab's data is open, got NDT data every day about the performance of the public internet. And we published it, MLab got the data, published it as fast as we could, which is increasingly fast. We now publish it in 2 hours, I think, after we receive it. It's super great. So this is all what I was told. I've had to figure this out. Rich Carlson is on the call. If I said something and he disagrees, he's right. But in 2014, I joined Measurement Lab, and now I can have a little bit of direct experience here. So I told people at the end of 2014 that I would like to do a quick hack to add WebSocket support to NDT. I figured, how hard could that be? Just like WebSockets, whatever. It took 6 months, and I also added the first unit test to NDT. Turns out I also needed to add TLS support. That took another 6 months. But eventually, NDT supported both WebSockets and secure WebSockets, and that server version was deployed to the Measurement Lab fleet. That took some time, it took some doing. And a partnership with Google Search occurred. I have no insight into how that occurred. But they integrated a secure WebSocket NDT client into the results for how fast is my internet. MLab and everyone else, because MLab data is open, got and gets so much data from that. It's so great. Unfortunately, there was sort of intersecting problems. There was a lot of technical debt, and there was legacy dependencies. MLab was running NDT, and therefore very old kernels with custom patches. MLab was running both Web 100 and V servers, and so we actually needed to, for the old Measurement Lab system, needed the MLab Web 100 patches and V server patches to apply cleanly. It was a nightmare. There's just not a tenable way out of that. There was no way to upgrade. The NDT code and Web 100 patches were too tied together. vServer patches got mixed in with there's 30,000 lines of decades old spaghetti. You can see the code there. The last tagged version in that code base was version 4. So we call it NDT4. I then, after my experience of adding WebSocket support, volunteered to write a new NDT server in Go that spoke the exact same protocol. Clients should not know the difference. Did it. It's available at that thing. So I started the protocol version for that server at version 5. So we called it NDT5. It worked, and it did not require kernel patches because instead of Web 100, it used Netlink and Tcp Info to get the data about the TCP streams. It still gets kernel instrumented data, but in the time since Web 100 came out, we've gotten a standard way of getting the in-kernel structs about the counters and stuff all associated with the flow. It's compatible with all the old NDT clients, we think. We don't have access to all the old NDT clients, so we can't bench test this claim, which is I feel bad about, but it seems to work. We deployed it and our test volume did not go down. So we think it works, but we can't prove it because we don't have access. So with this much technical debt all the way, NDT5 worked, but the Untitled protocol itself was bad. The Ndt5 protocol required Web 100 stuff in it. It actually specified that in order to be a Web 100, an Ndt5 server, you had to respond with these Web 100 variables. They didn't exist anymore. Also, there was no way to check that the server connecting to the port was the same as the server, that the client connecting to one of the ephemeral ports was the same as the client that had requested to connect to the ephemeral port, which seems like it obviously should be, but for servers like MLab servers that constantly are getting port scanned and all this, it led to some confusion because like open port 3005, okay, this client connects to 3005, or somebody connects to 3005, probably the client, but there was just too much badness there. And worse, NDT5 didn't work in a locked down network context. It required ports besides 80 and 443. And for a lot of clients out there, for a lot of people who want to run a speed test, they're locked down to ports that are to a really restricted range of ports, and they cannot access services on ports besides 80, 443, and one or two others. So we needed a breaking protocol upgrade, or something that sort of preserved the spirit of things. Researcher Simone Basso, and me, but mostly him, wrote NDT7. We called it NDT7 because NDT6 risked confusion with ping 6 and traceroute 6. So we just skipped 6 altogether. NDT5 has always supported IPv6, or if not always, ever since I've been involved with it. So let's not even worry about that. It's called NDT7. NDT7 is simpler, faster, easier, more usable, and all around better. Thank you, Simone. It's with the UNI project, the Open Observatory for Network Interference. They care about measuring the internet. So NDT7 is a simpler protocol. It's served on standard ports, 80 and 443. You connect to this URL, and because it's a URL, we can get finer grained controls. You perform a 10-second WebSocket download. You connect to that URL, you perform a 10-second WebSocket upload. Server measurements are sent along the WebSocket being measured, so we don't need a separate control connection in this. It's just comes down the pipe. There's this sort of chaff filling up the data channel, and then every now and then there's a message contained in the chaff saying, hey, this is one of the measurements. No multi-socket coordination, no control channel, web native, CLI is still easy, and it's actually very simple to write a client for, particularly for the download test, which is nice. So that's it. We now have an NDT server code base. It's one code base serving both NDT5 and NDT7. So we're not going to stop serving NDT5 protocol results. And if you have old existing NDT5 client footprint, you can still run them against this code base and it will work. This service and it will work. It's 4,200 lines of code, down from 30K, which I'm really happy about. Less code is less problems. It's unit tested. It's 1,000 lines of unit test. That's growing. I anticipate it growing more than doubling. It runs on stock Linux kernels, at least stock modern Linux kernels, and it's monitorable with Prometheus. So if you're the kind of person who likes monitoring things with Prometheus, hey, you can do that with the NDT server. You can run it yourself. If you run Docker, you can just do it with this one command line. Docker run says start a Docker image, -it says do it interactively and in the terminal, so Control-C will actually stop the thing. And --net equals host says you got to give this permissions to run in the host network context rather than creating a network namespace, because for the opening of ephemeral ports, you need to give it control over the local, or you need to pass that in for the ephemeral ports for NDT5. And there it is. And the image is called NDT server. And if you do that, you too, like you can do it right now. Some of you might be typing it right now. I would encourage you to type it right now. there you go. You can run it yourself, and you can build it yourself, and it should work. If you can't run it and build it yourself, if you can't run Docker, you can build it yourself. You can download the code, run build.sh, and then an NDT-server binary should appear in the local directory, and everything should work. That's been verified to work by at least some people on the mailing list, because not everybody can run Docker. All right, so this NDT server is currently deployed worldwide. It's serving millions of tests daily, millions of NDT5 and some, but very few, NDT7. It's really millions of NDT5 tests daily. You can use NLab's NDT server to test against, which here's where they all are, or you can run your own. And the server produces data in JSON format, which I think is really nice, because the JSON is sort of very generically parsable by a lot of tools, and you can grep it, and you can, it's just really nice to have a nice textual format that is nice and standard. There's NDT7 clients available. There's a Go client called NDT7 Client Go. There's a JavaScript client. It's shipped with the NDT server, actually. It's under active development. There's a Node.js client that's under active development. That's what I would be doing if I were not talking now. And there's a C++ library. All of these are NDT7 clients. These clients are easy to run. They were easy to write. The client code size is small, and the code is well tested. The thing that I'm happiest about with NDT7, and that I'm trying to proselytize, is writing a speed test client is now easy. And so think about maybe doing that if you want to test speeds, because it's easy now. Even the C++ one, is remarkably simple. Along the way, because remember how NDT became a dessert topping and a floor wax, it did all these things, and people liked all those things. And then I built this new NDT server, and it didn't do all those things, and so some things are missing. And we wanted to not take those away from people. We wanted to make sure that we provided people with similar functionality. Here's a service called Tcp Info, which actually will instrument all TCP flows and save the data. So you too can have basically sort of Web 100 style metrics on stock kernels. It just runs, and there you go. There's a system called packet headers, because remember NDT used to save packet headers, and now that's not a feature provided by the server anymore, or by that binary anymore. It's provided by the packet headers binary. Packet headers binary captures packet headers for all TCP's flows on the system and saves them. And there's a system called traceroute caller. That was something MLab always did, but it's not something that was built into NDT, but it sure was handy, which will traceroute after the close of every TCP flow on a system and save the resulting traceroute. And then there's a UUID system, which gives every TCP socket a universal unique identifier. And that's really, really useful for joining application data with the data produced by these sidecar services. Because if you've ever tried to join data collected by different services in different contexts, you end up doing like network 5 tuple and fuzzy timestamps, and you're never quite sure when you don't find matching data if the matching data really is matching data. And if you do find matching data, you're like mostly sure you found the right match, but you're not like 100% sure. It's really tough. But with the UUID system, all of a sudden you get an unambiguous string, and if the string that uniquely identifies that flow is present in TCP Info, then boom, there you go. You have a TCP Info data for that stream. If there are packet headers, it's there. If there's a traceroute, it's there, and you can unambiguously determine what data is available for what flow. So these services provide NDT-like instrumentation to all services that use TCP. So we took the NDT server, we split apart its functionality, and we made some of its functionality global to the system, which I think is going to be of interest to people. And now I promised I'd give a live demo. So I thought people would like to see that it really is pretty easy to run your own NDT server. So let me try. You've all given live demos or seen them, so you know the risks involved, which I appreciate. let's see. If I am to, so the first thing I wanted to show was that that command line that I gave you actually does work. And in order to do that, I think the right thing, we're sharing the whole screen, so I should make this terminal a little bit bigger. We'll increase the font size. The text should be custom font of size 20. There we go. So what I promised would run was docker run -it. And now we have to give, give localhost privileges to it, -net equals host. And then the image was measurement lab /NDT -server. And if we do that, pulls it down from Docker, downloads it from the public Docker hub, and there it is. If you produce some data that's a little bit hard to read, but it's about to listen for unencrypted NDT5 tests on port 3002, and it's listening for NDT7 clear text tests on port 80. It worked. So let's go to the web browser. In the web browser, go to localhost. Okay, this message is a little bit outdated. Sorry about that. But there we go. And when tunneled through a web browser with a few bugs in the JavaScript client that I'm working on, we're getting 507 megs. And in upload speeds, we're getting 1.3 gigs. This is mostly due to weird limitations within the web browser, and I'm working on it. That 576 should be bigger. And I guess the thing I also wanted to show was that it really should be bigger, because if we go to this directory, I happen to have a Node.js client here. This is the one I'm working on. We can see that it's actually, connecting to localhost, we're limited by memory bandwidth, and this client is getting really very fast speeds, which it should be, right? That's memory bandwidth, it's not network bandwidth. But to show that it works, I think that's important and good to see. So NDT works. Oh, can I blow up the screen? Is this, Jeremy, is this good enough to blow up the screen? Did I blow it up enough, or should I blow it up more? Okay, good. I just noticed.
You're good.
All right. Sorry, I just noticed the message. So we can see that we can test to a server. You can run your own speed test server, and I guess you have to take my word for it that this is just a sort of pretty standard server, standard Linux server, but it is. It's a cloud-based Linux server, and it's running the tests, and it works just fine. And I think that's really important and good and relevant to your lives. If I were, now I'm going to really step in it and go to this. I had previously hard-coded this client to use localhost, so I'm going to not do that. Now it's going to use the MLab infrastructure. And when we run this one, it's testing to Nuco 7, which is in the Bay Area, and it's getting 300 megs. And there it is at 77 milliseconds. And then for the upload test, it's getting 270 megs. And if we run it again, it'll test to a different server. this is more like what I expected to see. This is to IADO5, which is much closer, 12 milliseconds away, and the bandwidth down and bandwidth up make a lot more sense. Or that's round trip time, so it's 6 milliseconds away. So it's an NDT server running a simplified NDT protocol, able to connect at gigabit levels to Shure. Andy Fleming says he sees the same browser limitations on download speed at speedtest.net tests from all browsers versus their native. You're right. There are a few tricks that we've discovered that we think actually work around that. In particular, a lot. So the antivirus, the presence of antivirus stuff is real, and actually constrains how fast users can use their network. So if you're on a multi-gigabit link and you think you can push all your network traffic through a antivirus system, then we are correctly measuring that you can't. But for ones that are more sort of straightforwardly connected and don't have the antivirus thing, there are a few tricks that we have been able to employ that we've just not yet ported to that one JavaScript client that look very promising. And we think we'll do much better beyond that. I don't actually know why this particular demo get much higher numbers than that. It was, again, the reliably hostile live demo gods. So this is a great show. We've shown you that we can run our own client, run our own server, run connected to the local server, and also connect to MLab's global network of servers. So we've got servers all around the world. We've got a service you can use, and we have what we've been calling sidecar services that give you access to all the things you might want, or at least that we think you might want. And so that is what I wanted to tell you today. There's an NDT5 code. There's an NDT code base. NDT is a protocol and a code base. The code base kind of fell apart, but we've kept the protocol NDT5 and written new code. We've also created NDT7, a new protocol that's all around better. It's all open source. Please use it. Michael Lambert asks, is the NDT7 server tied to Linux, or will it also run on BSD? The NDT7 server, I didn't put this here, requires BBR. So anything that BBR has been ported to, it will work on. The status of BSD's BBR port is currently unknown to me. But the basic principle is that according to, let's see, the model-based metrics RFC, I think 8337, actually has a sort of interesting thing to say about the philosophy of science. It says you can't actually share data across network contexts. You can share models. That is, you do curve fitting, you say what it says about the network, and then you can share those network models across contexts. Like what conclusions about the network does your data come to? What conclusions does this data come to? BBR contains a model within it. It actually contains a model where it models the network's bottleneck bandwidth and round trip time, and we use that kernel's model to make our data, and so we depend on BBR. The current server is indeed single stream. BBR single stream and BBR multi-stream turn out to have basically the same results. Matt talked about BBR I think Matt Mathis talked about BBR a little while ago. So we don't have any plans to make NDT7 multi-stream because multi-stream BBR and single stream BBR be seen in the same location. There's no actual advantage there. Or at least we've never seen an actual advantage. Like you can try multiple tests in parallel and they don't do any better. Are there any other questions that I can answer from people? I'd like to go back and to talk about these other fun services as well. TCP Info. So TCP Info is an attempt to, oh wait, are there any NDT7 clients or server combos that give recommendations and guess things about the network like the old legacy perf sonar stuff did with NDT? No, and one of the big problems with NDT is that that expert system was never upgraded and never, so as network content, as the internet changed, the recommendations kind of didn't. The new NDT protocols mean that, especially the NDT7 protocol, means that the client has all the data the server does, which means that now making those predictions and doing that expert system stuff is a function of the client, not the server. And no one's written a client that does that because NDT7 only just now sort of hit the streets. But that's really the job of the client. The server has enough of a job just performing measurements in a reliable fashion. So no, unfortunately, but I'd like there to be. And if anybody wants to write one, I'd love to help you out and hold hands to get through NDT7. TCP Info provides, I think, what Matt referred to as the dream of Web 100, but for everybody. Packet headers is super useful. Traceroute caller is super useful. And UUIDs, I just want to tell you, are so helpful. So helpful. So I'll start with Rick and then go to Jeremy. This really relies on extracting data from the kernel, and it isn't clear if the existing kernel variables provide the necessary data. That is true. I couldn't tell you. I never maintained that expert system that you wrote, Rich. I'm sorry. If Rich says it's unclear, then it's unclear. And Jeremy says, is this related to the above? One of the things NDT did was guess whether you had a duplex mismatch or not. It was useful in a large decentralized campus environment. Does this functionality still exist? There are no clients with that functionality, and the server no longer has that functionality. It's sent it to the client. Duplex mismatch was one of the easiest things to determine. I can't, that would be very easy for a client to determine. Yes. Matt asks, is there a good place to get the NDT7 protocol definition? Yes, there is. As a matter of fact, Simone produced a protocol spec for it in, I believe it's NDT7 / it's either NDT7 / spec. No, I looked in the wrong place. Sorry, it's NDT server / spec, NDT7 protocol. And here you go. It's versioned, it's design choices, it says things like non-normative and uses that kind of nice RFC language that hopefully makes writing your own client very easy. And yeah, here you can see a great example measurement, although in reality, there's a lot more elements to the TCP info struct. And there's just more elements there. But there you go. So NDT7 available for networks, available for campus networks. It can be, yeah. Are there any other questions? I think I might be done in a record 36 minutes. I will pause sharing my screen and go back to camera, I think.
Yeah, so thank you again, Peter, for doing this. I have a couple that I could ask, but we'll certainly poll the audience here. I know there's several very vocal people that probably have questions. And there we go. Andy has another one. Oh, never mind. He just has a comment. So the first one that I wanted to sort of noodle on a little bit is it's related to the old functionality of NDT and sort of, you know, how would one go about trying to pull some of those heuristics out? Because I think a lot of us represent campus networks or regional networks or national networks where we're looking for we're looking for the ability to deliver a tool that somebody can get to from a web browser, and be able to tell them if their end is broken or your end is broken, and generate a trouble ticket or something like that, that would then allow us to go out and debug things. And tools like Persona help with this, but Persona tools are sort of server to server, and this NDT, the old NDT, and even the new one is sort of designed for the laptop and mobile user and things like that. So if I was an enterprising grad student with a free weekend, how do I get started? What do I look at first to sort of develop a diagnostic tool based on what exists there today?
So it depends on what. So if you're an enterprising graduate student, that means you're probably the kind of person who likes to hack things together in a weekend. So then the question really is, what languages are you already comfortable with? Because all of the clients that I linked to in the presentation, at the end, or wherever I linked to clients, yes, the Go client and the C++ library, but especially the Go client and especially the JS client shipped with the server, actually. Both of those are really, really small and really, really simple to hack on. They present their data almost in raw form to the user. It's just a log of a JSON message by default sometimes. So you can really just say this kernel variable, that kernel variable, this kernel variable, that kernel variable. When we see one big and one small, that's a duplex mismatch maybe. When we see this one big and this one small, and when we see this RTT not match that RTT, then we know something else is on. Adding those smarts to the client should be very, very simple and very, very straightforward. Both the JS client I know for sure because I've been working on it very recently. You get a last message that is a summary message of all the kernel variables around TCP flows, and so whatever you can conclude from those kernel variables, you can conclude right there in the client. Does that answer the question? Like, just hack on the JS client. It's really, really simple. And when I say it's really simple, I guess, why don't I back that up? Here is the complete Node.js client. And of course, here is the complete Node.js client. And of course, it looks like a disaster, but I guess what I want to show you is that there are 33 lines to this file, and that is the complete client. Everything else we send to you. And so for the NDT7 test, there is a server chosen callback, a download measurement callback called on every measurement, a download complete callback called once the download test is complete, an upload measurement callback, an upload complete function, which doesn't currently do anything, and then we exit. And that's it. So if I were an interested graduate student, I would work on making an array from the download measurements that I received, and then on the download complete callback, doing some analysis of that array of measurements, of that array of timestamped measurements. And I don't think that would be very hard to get some basic, interesting things in.
Nope, that answers it. Yep, that answers it perfectly. And hopefully this is something that those of you that have the ability to find graduate students can point them to. I think that if we want to see the functionality that some of us sorely miss within this space, we're going to have to recreate it. And this is already a great start to sort of getting there. I guess the second and related question, oh, go ahead.
What I was going to say is also MLab, I really want to be supportive of this work. So if they need code review, if they need help, please tell them to send emails to support@measurementlab.net. I and others monitor that email address, and we will get back to them because we really do want to help people build this kind of functionality. I can build a server, and I can get that server running around the world, and I can keep it running around the world, and I can help with all that stuff. Adding on everybody's differing client needs ends up being sort of a straw that breaks the camel's back. So we would love to help people build their own clients and publicize their own clients once those clients have been built.
Certainly. And related to that, and you queued it up perfectly, is for those of us that do run campus networks and regional networks, what is sort of the barrier right now, or how does one go about contributing server resources to MLab? It's been many a year since I've looked into this. I remember it was a little bit onerous sort of in the start, but it sounds like deployment of the code base is a lot simpler. You know, how can one go about contributing such that data can be contributed back to that project, and in return, you know, also getting a little bit of a status of your own network as a result of it?
So MLab took a turn, and we've now mostly been concentrating on making sure we are properly measuring the corporate internet, the third-party data centers and stuff. NREN networks occupy an interesting space. We Measurement Lab try to deploy our Measurement Lab servers physically and logically adjacent to content servers. So some NRENs serve a lot of content, and some don't. And I don't know which kinds of networks you have. And I would bet that there's different kinds of those networks here. Measurement Lab is a little bit less interested in being involved in those networks. I would, however, point you at the EdgeNet project, which is designed to sort of be a successor to Planet Lab and to provide that easy scale out of resource and resource donation. And they're looking to get much closer to the user edge and do not have this weird, we'd like to be physically adjacent to content problem. If you want to but if you would like to run your own NDT server, not with MLab running it, just you run your own, I think that you are empowered to do so in a way that it was really hard before. It used to be really, really hard to run your own NDT server. You had to compile patch your own kernel, boot it up, and then all of a sudden now you have this custom kernel that you have to manage the deployment of. And it was hard. If you take away nothing else from this talk, I want you to get the idea, the true idea, that running your own MLab server is now easy. And now that it's easy, we'd appreciate it. There's a whole donation of resources process. We'll take a /26 out of your network, which is complicated. Do all that stuff, but in terms of running your own server, if you would like to run your own NDT server, you can just do it, and it'll work, and you don't have to go through us, and you do it yourself, and that's what I would encourage.
Okay, that's good to know.
It used to be to get to the MLab instrumentation, you really had to go run the whole MLab stack, and if you're running the whole MLab stack, you might as well get MLab to run it. But now, stock kernels work, and that's, I think, the most helpful message I can give. So,
all right, thank you.
Rick said the key is updates to the server providing the data needed to make determinations. I've thought about how to get more data in the kernel. Time will tell if this is workable. The other idea is to define exactly what kinds of problems the community wants to automate. I will say that right now the NDT7 client is set up to just transparently pass through whatever is in the Tcp Info struct, and the Tcp Info struct is extensible. So Rick, if there is data that you need the kernel to emit, it can actually go at the tail end of the TCP info. It can go in a patch that puts stuff at the end of the TCP info struct, and that data will be transparently emitted by the NDT server. So if you do upgrade your kernels to output more instrumentation, that instrumentation will strictly be a pass-through through the, or it should be, I hope it is, I think it is, a pass-through through the NDT server out to the user. Matt Zukowskis asks, how does finding an MLab server work? Could we have a separate set of RNE servers? So let's talk about that. Finding an MLab server works by using what's called the locate service. There used to be a specific instance of the locate service called mlab-ns, but we're trying to push people to locate.measurementlab.net these days. And if you go to locate.measurementlab.net, you'll get this map. That's the thing I had screenshotted. But if you specifically request like /NDT7, that will return the name of a server that is supposed to be near me. I don't understand why this server is not near me and it's instead in Singapore. I think that's because this particular machine is inside a Google data center, so its egress paths are strange. But I reload this and I'll get something in New York, something in Miami, something in Athens. So I'm getting load balanced all around the world from this one machine. And just hit the URL. locate.measurementlab.net/NDT7. And that URL will get you a nearby NDT7 server. It is absolutely possible to make a set of RNE servers. Unfortunately, we're a small team, so but all of our code is open source, including the locate service, including MLabNS, including the locate service, including NDT. Like we have no proprietary anything. It's one of the reasons I'm very happy Google assigns me to work on it. There's no secrets there. It's radically open data, radically open source. It's all available. So if you want to run an RNE one, you totally can. In the fullness of time, we are trying to build multiple people have asked us about having classes of servers associated with our network. It's hard. We have a lot of stuff that assumes right now that everything's kind of the same. It's not to say it's impossible, but it's not our priority list, right? Right now we're trying to get NDT7 everywhere, and we're trying to increase reliability because Google search uses us as a thing, as a service, and so we want to be very reliable. Even though we don't promise to be more reliable, we just sort of feel it. We really want to be reliable, and we want to make sure our data is transparently available. And so those things are occupying the bulk of our time, fortunately. Can NDT server run in an unprivileged container without access to the host network to measure the performance of the overlay network, like with Kubernetes? NDT7, so I believe, but have not tried recently, that NDT7 can, but NDT5 cannot. And this is because NDT5 depends on the ability to open ephemeral high-valued ports and have those ports plumbed through. And Kubernetes has the model that a given container will only use a particular set of ports, and only those ports will get plumbed through. So that's sort of a protocol level incompatibility. But I think, but have not tried, that NDT7 will be able to test overlay networks. So hopefully that answers your question, Igor. Are there any more?
All right. Yeah, and I'll echo Rich's comment there. Keeping this going is certainly a great thing, because there were a lot of legacy deployments and people still kept this tool in their toolkit when they needed a go-to test from a web browser. So this is great work, and thanks again for giving the community an update on this.
No. It's just wonderful that there's people besides us who care about it. Again, support. I'll type it in the chat just to make sure that it's here. But support@measurementlab.net is a great email if you have any questions about getting things running, keeping things running, all this stuff. We want to help people out, and we will keep on deploying, and we'll post to our blog when we do more stuff. There's an NDT7 post in the works, because we want to tell people about it, but we also want to get that JS client really tuned before we do. So yeah, thank you very much. And Lai Yi, who is the director of Measurement Lab and does not work for Google, says that MLab hosts community calls as well. Please write to support@Measurement Lab if you'd like to be included on that invitation list to the community calls, which are also great for keeping up with this work.
We forward those announcements to this mailing list, so hopefully you've gotten a couple from there. All right. Well, thanks again, Peter. If you can send me the slides, I'll make sure that those get posted, and we'll get the video uploaded a little bit later today as well. For everybody who is still on, next week's talk is going to be about Zeek, the open source intrusion detection system. We're going to be trying something a little bit different. It's not necessarily going to be a talk. It's going to be more of a tutorial. So if you have people on your campuses that want to learn how to deploy Zeek, it's going to be a very, very entry level and approachable thing. It's going to be given by an expert from the Zeek field. So hopefully that'll be useful to people as we are all still confined to barracks. So hopefully we see some people next week. Hope you all have a good weekend, and we'll talk to you all soon.
Thank you again. Bye.